Okay, isomers again. You really want to focus on this. I know usually there's, in a class of say 20, you usually have about 3 or 4 people that just have a real hard time with isomers. So we have draw 4 isomers of 1 hexane. I should say 4 isomers with the same formula as 1 hexane. So there's only one 1,1-hexane. So, but let's draw it out first. 6. There is 1 hexene, I should say. Sorry if I've been saying hexane. 1 hexene. And so we need to have the same formula. So this would be C6H12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so we need to have formulas that have the same, or structures that have the same formula, but different positioning of that double bond, maybe some different branchings, but the structures should be different from one another. So one nice thing when you're dealing with double bonds like this, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. We need 4 of these. Here's one. We've just moved the double bond from position 1 to position 2. This is 2 hexene. That's 3 hexene. Those are, so this is what we started with. We need 4 new ones. So if you get used to these line angle drawings, it's really nice because you can work with them very quickly. Well, let's see. We can't move the double bond down the line because if we move it here, then it just becomes this structure, so that won't do. So we go to 5 carbons, put the double bond on the end, do a branch. That's definitely different than the other 2 because we have a branch now. And then if we did this, put the branch there, and that double bond gives us a lot of extra flexibility. Now we could go and put the double bond. We only need 4, so we can stop here, but we could keep going. Put that there. That's different than anything that we've seen previously. So a lot of play there. All right, let's try this one. 5 isomers for 1 octene. 2, 4, 6, 8. That's octene. That's octane. Now it's at 1 octene. And what I would suggest before anything else, just move that double bond down the line until you create. So this is what we started with. We need 5 new ones. Same formula. By moving that double bond, it's the same formula, and feel free to count up the carbons and hydrogens as long as 1, 2, 3, 4, 5, 6, 7, 8. It has to be the same. And now, if we go any further, then with the double bond, just moving it down, then we're creating the same structures as before. So 2, 3, 1, 2, 3, 4, 5, 6, 7. That's 7. Put the double bond here, and test it out. Check the formula. Go back to the, and you should find that it is what it would be. So C8. H16, so 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oops, 1, 2, 3, 4, 5, 6. Oh, there's 1 there, so 16. But yeah, you should come back to that same formula. The formula is C8H16 for each of these. And the more you do with these line angle formulas, the easier it will be to come up with these isomers, and very, very quick. It's just make sure, see the double bond, the same structure, except the double bond has moved 1. These are definitely different from each other, so that double bond really helps out with the isomerism. Okay.